How are you? How are you? Are you there? Can you hear me? Are you there? Can you hear me now? Good morning. Good morning. How are you? Are you okay? I'm very well, thank you, Julia. Very good, very good. Hello, Sarah. Very good, very good. So, now please, you need your social science notes before you. Today our class is composed of three things. One of them is about fishing in Spain. Then we're going to watch some video clips about mining, and then finally, I've received a gift from Miguel Farias. Okay, a presentation about a very famous writer, but this will be at the end. Now, please, we're talking about fishing, and as you may know, Spain is one of the most important fishing countries in the world. So most of the catches of the Spanish fleet does not come from the seas surrounding the peninsula, as you know. And there are two different types of fishing. One of them is called inshore or coastal fishing. You can see this image here about this kind of boats that represents the inshore fishing. Okay, so it's the thing is that fishermen and women use handmade tools, small boats, and return home daily. This is important. So if you are a fisherman or a fisherwoman, it's in this case you every single day you are returning home. Okay, why? Because you are practicing coastal fishing and you use this kind of boats. But maybe you can be a sailor or a fisherman or woman that are working offshore and practicing deep sea fishing, and in this case they use industrial methods, large ships, and they can work for weeks or months without returning home. In this case they use modern methods of fishing with fridges inside these boats. This is different. In Spain, the whole of the coast of the Mediterranean Sea practice coastal fishing or inshore fishing, and they catch species such as anchoas, sardinas, and mackerel. So it's the English for our Spanish caballa. Very good. But if you like to eat tuna, hake, swordfish, monkfish, or crustaceans, you need deep sea fishing. And you have here a kind of map, and you can see here some important ports or harbors in Spain. So the whole of the Cantabrian Sea, along with the Mediterranean Sea, this coast in Spain, in Galicia, but as well this coast in western Andalusia, they practice offshore fishing. Can you see here the color? This purple color means that in these places they are practicing offshore fishing, which means that people, sailors and fishermen go offshore and they remain there for weeks or months. Maybe they are catching fish in the Atlantic Ocean or the North Atlantic Ocean. Okay, so they can return home daily. But in the case of the Mediterranean Sea coast, Spanish coast, all these people here that are practicing fishing, they normally return home every single day. Okay, so this is the two different methods of fishing. Okay, it's in this table you can see some important ports in Galicia. The most important ports are Vigo and A Coruña in Galicia. The Cantabrian Sea coast, you have Pasajes, San Sebastián, Ondarroa, Bermeo, and Gijón. Maybe you remember a Basque song I told you one day about Ondarroa in euskera. Agur, Ondarroako, Ondarroa. Good. And the Atlantic Andalusia is the third Spanish region in terms of tonnage. Tonnage is the amount of fish that they are able to catch. So most of the fleet works in the Saharan banks, and the major ports are Algeciras, Barbate, Cádiz, Huelva, and Ayamonte. All of them are Andalusian cities or municipalities. Then we have the Canary Islands. It's this region practice deep sea fishing. Las Palmas is the most important Spanish fishing port. And finally, in the Mediterranean coast, all its fleet is inshore. Its notable ports are Castellón, Valencia, as you can see here. Very good. And now about mining. Mining, this is very interesting. We have different types of mining. We have surface mining, we have underground hard rock mining, and seabed mining. And you have here the characteristics, the features of minings. These minings are extracting products that are close to the surface, so you don't need to drill a hole in the earth. Okay, it's some products are granite, coal, copper, marble, slate, and salt. Okay, these products are hauled with surface mining. But if you want to take gold, silver, iron, copper, zinc, nickel, tin, or diamonds, for example, you need to practice underground hard rock mining. This is a very dangerous work. But today we are going to see some different methods to extract these products. And we also have seabed mining. Seabed mining is important to retrieve nickel, copper, platinum, lead, plomo, zinc, gold, and silver. Okay, very good. So these are the three different methods. And now I'd like you to watch some video clips about some methods to practice mining. We're going to see a method that is called room and pillar mining method. Pay attention to it.
Room and pillar is a common mining method for mining ore bodies with a dip less than 50 degrees. There are different variations.
So this is the idea where mining is going to be practiced. Okay, and pay attention to this device, because this device is off surface. This is the inner surface and this is off surface. Pay attention.
Of the method, depending on rock conditions and the dip and thickness of the ore body. When
pillars, these are pillars and these are rooms. Okay, pillars and rooms, and this is underground. All this part is underground.
Mining the ore, a grid system of open rooms, together with a system of pillars to support the overhead rock mass, is created. The mining sequence can be optimized to accommodate rock conditions and ventilation demands.
Remember, this is underground. You can't see them working here.
The ore is usually mined.
Ore is the English for our Spanish mineral, ore. They are extracting ore, maybe about some nickel, copper, tin, whatever. Ore, mineral.
Out using the same drill and blast technique as in conventional drifting, where the drift becomes the room between the pillars. The process itself.
They need ventilation. They need oxygen. Okay, this tube, this pipe produces ventilation.
Holds a number of sequential operations, where the number of activities varies depending on ground conditions and
now in this moment they are supporting the surface, okay, because otherwise this can fall down.
Design criteria. The key to success in room and pillar mining is to establish the optimum sizes of the rooms and the pillars to recover the maximum amount of ore.
Okay, so the pressure of the whole system rests on these pillars. So they have to be very careful to scale these pillars. Okay, so the stress of the rocks is very important. Okay, if they don't do it carefully, the whole process can collapse.
And leave the smallest possible pillars behind without compromising safety. Room sizes and
this is room, okay? So this is underground, and they need to take all this ore, okay? Maximum they can. And this is the room, and this is the pillar.
pillar dimensions are based on rock conditions and predicted rock stress changes that may occur when mining. To ensure safety in areas with a larger roof span, rock reinforcement, such as cable bolts, are sometimes required, in addition to rock bolts. Accurate drilling and good blasting practice minimize overbreak and blast damages in the pillars.
They need engineers and architects to plan all this work, okay? They need to success, because otherwise this could be very dangerous. In the past, many miners died inside mines, so they don't want it to happen again.
Plays an important role to keep the strength in the pillars, and therefore preventing pillar failure.
Remember, this is underground, you can't see it, and these yellow tubes, these yellow pipes, are producing ventilation. They need to renew the oxygen for the workers to work.
As the ore is being mined out, roadways for ore transport and infrastructure are created inside the production area. Working at several production points enables efficient use of equipment. Various transportation methods can be used for transporting ore to surface.
And this is the ventilation shaft, okay? So this is the pipe by which all the oxygen comes to underground, okay? For the workers to breathe.
A well-planned room and pillar mine is flexible to changing commodity prices on the market and can quickly respond to changing market conditions. Room and pillar is a productive and flexible mining method that comes with a certain degree of ore loss.
So can you see? This is the surface. This is the surface, and this is underground. This is the surface. You can play here, okay? But here, this is underground. This is the mine, the modern mines.
For both small and large-scale operations.
Okay, very good, very good. Now, if you like it, wait and see the next method. In this case, we're going to see the differences between the subsurface and surface mining. Pay attention. this is surface mining. You want to get granite, okay? You don't need to make a hole like in this case. You want to retrieve gold, silver, copper, or petroleum, oil. You need to make a hole there. So I want to see the difference between surface and subsurface mining. Subsurface means underground mining. Okay, so this is the first idea. Surface mining is a type of mining in which the surface layer of the earth is removed. So you have vegetation here, for example, that are covering all this part, and you want to get this ore. You need to remove all this surface. That's why this is called surface mining. And there are various rocks or minerals or ore that are obtained. So coal, lignite, okay, granite. Okay, so the surface of the mountain top can be removed. So this is surface mining. So this is the process. First, the soil and vegetation is removed. So this is the soil and vegetation, and you want to get this ore or these materials. You have to remove all this part. All this part. They use explosive, okay? They use explosive today, okay, to take out these rocks. Now, subsurface mining. This is underground mining. You need to drill a hole there. So you want to get gold, diamonds, but copper, tin, nickel, petrol. You need to practice subsurface mining or underground mining. And this is the image, okay? This is the tunnel. They need to make tunnels here. And this is the room we saw a moment ago. The room and pillars. These are pillars, and this is the room. First, you got to practice a vertical underground shaft. A shaft is a kind of hole. Okay. So first, this part. This is the first thing you have to do. Okay. And you need miners to take out all these products. First. This is the first step, okay? And then you have to build this kind of tunnels and this other kind of tunnels. There are the differences. So this is surface mining. Remember, you only had to remove the vegetation and the soil that are covering the place you want to extract the ore. It's relatively safer and easier than underground mining. And underground mining or subsurface mining is practiced beneath the surface of the earth, on the ground. Okay, and it's very dangerous and life-threatening. if you want to practice mining, you need to destroy the environment. So this is the bad thing. This is the bad side. And people are asking themselves the methods to better protect the environment. So if you are environmental friendly, you have to be aware that mining destroys landscapes and the habitats of a lot of wildlife. The pollution is created with the kind of mining, and is very bad for the animal life that are living there. It's underground mining or subsurface mining is better for the environment, but is very dangerous for the people. Can you see this image? This is a very old image about miners. Miners had a very hard life in every country. In Spain, you know, was one of the most important countries in the world about mining. Okay? That's why many people, many clans, tribes came here in Spain to get minerals. But today, all this is over. Okay, do you recognize these two people? You recognize these two people? This is an American presentation. Okay, you recognize these two people? This one and this one? I'm waiting for your answer. You know who they are? This taller person and this smaller person, you know? Yes? Okay, very good. Now let's go back to our notes, and we have there some text about mining in Spain. This is important. This is very important. So mining in Spain. This is a photo of Almadén. Almadén is a very interesting municipality in Ciudad Real province that belongs to Castilla-La Mancha, you know. Okay, so almost all known minerals were found in Spain, and because of that, we were invaded by the Phoenicians, by the Carthaginians, by the Romans, because one of the things they wanted in our territory, in the Iberian Peninsula, were minerals. In Almadén, Ciudad Real, there was the richest mercury deposit in the world. But today, this is totally over. Okay, Spain was the largest EU producer. EU means European. In the European Union, you know that Spain is a member country of the European Union. But Spain was the largest EU producer of lead. Lead means plomo. Think another precious metals. The economic development of areas such as Asturias and the Basque Country was based on their mineral wealth. Okay, and you have here surface mining. This photo was taken in Aznalcóllar. In Aznalcóllar, there was a very dangerous situation some years ago. Aznalcóllar is a municipality that belongs to Sevilla province, and nowadays mining has lost its former importance in Spain. However, the most notable mines remaining in Spain are to be found in Jaén, lead, this means plomo, Aznalcóllar, zinc, Huelva, copper, and Basque provinces, Asturias, León, Andalucía. So Andalucía, Jaén, Aznalcóllar, Huelva, and some iron mines there, as well as in the Basque provinces, Asturias and León. Very good, very good. And with that in mind, I have for you another interesting documentary about I think we want to watch the method they use to take out oil and gas. Pay attention, because we're talking about seabed mining. Pay attention here.
These potential impacts and other possible hazards associated with drilling activity. Oil and gas, also known as hydrocarbons, provide much of the energy needed to power homes, cities, and industries around the world.
So we're talking now about the extraction of oil and gas. We need oil and gas in our daily life.
Offshore wells are drilled by companies to discover oil and gas, or to develop and produce already discovered reservoirs to process into usable energy.
And these are plants. These are plants on the ocean. These are plants to extract oil and gas. Okay, and this is the place where many choppers are landing down here.
Woodside is Australia's largest independent oil and gas company, known for our world-class capabilities as an explorer, producer, and supplier of energy. Over our 60-year history, we have safely drilled over 600 wells in offshore environments, both in Australia and internationally. Before drilling, Woodside undertakes detailed well design and logistical planning.
They need to plan before drilling. They need to plan the whole work. Okay, this is an Australian video clip. Okay, and this is a video clip from a company, an Australian company. They explaining us the way they follow to extract oil and gas. It's very interesting.
Applying good industry practice to ensure our wells are drilled safely and potential impacts to the environment and other marine activities are minimised. We consult with stakeholders, including local communities and fishers, to explain our planned activities and understand how...
They say that first, before starting working, they meet with all these communities to explain them the benefits of this drilling.
Potential impacts can be avoided or minimised. These potential impacts and other possible hazards associated with the drilling activity are monitored and managed throughout drilling operations. Woodside also prepares environment plans that detail how drilling will be undertaken and obtain approval from relevant regulatory authorities before drilling commences. Wells can be drilled by either a drill ship or a drill rig, known as...
Okay, so you want to extract oil or gas, you can do it with a ship or with a plant. With a ship or a plant.
Mobile offshore drilling units or modules, depending
and this is a plant. Okay, this is a plant.
On water depths and other factors. To ensure the safety of other marine users, vessels not involved in drilling should stay at least 5...
Okay, so they need some ships here, okay, far away, 500 meters from the plant, okay, to be safe.
500 meters away from the drilling location while in operation. This is called a safety exclusion zone. Once the well is complete and drilling infrastructure is removed, marine users are generally free to resume normal activities. While technical differences exist, the process for drilling all offshore wells is similar and take place in several stages. Before any drilling, a remote operated vehicle or ROV is sent to assess the condition of the seabed.
Okay, so before drilling, they need to be sure that here they can find oil or gas, and they send this device, this machine.
A hole is then drilled into the ocean floor using a large diameter drill bit. And steel pipe called a conductor is installed, providing the well's initial structural support. A smaller drill bit is then lowered through the conductor to drill the next section, which is called the top hole.
So, can you see? Can you see? This is the device that is drilling here, okay? And it's going down, down, down to find the right soil where they can find oil or gas.
Once it reaches a predetermined depth, more steel pipe called casing is installed, supporting the newly drilled hole. Cement is pumped through the casing.
Now they are putting cement here, okay, to make sure the casing of this device, this pipe.
Moving between the casing and the drilled hole, securing it in the ground. The cement is allowed to set before drilling continues. Before drilling deeper, a blowout preventer, or BOP, is installed on top of the well. The BOP is a large, specialised safety device used to seal, control and monitor wells to prevent uncontrolled release of fluids.
Okay, so this is put here. This is put here to prevent any leaks or fluids here. Remember, this is the bottom of the sea. This is the sea floor.
After the BOP is secure, a smaller drill bit is lowered into the hole to drill further, and more casing is cemented into the ground. This step is repeated until the well reaches a specific depth where the targeted reservoir is predicted or known to sit. This is called total depth and can be several thousand meters below the sea.
Can you see here? Okay, this is the plant, this is the ocean, this is the seabed, the seafloor, and they are looking for this part here. They know that here they can find oil or maybe gas, and this is the drilling. This is the pipe they're using. Remember, that's the ocean, and this is a plant.
Seabed. Drilling fluid, sometimes called mud, is continuously pumped into the hole while drilling. This helps keep the drill bit lubricated and cool to prevent overheating, prevents the uncontrolled flow of wellbore fluids, and transports drilled rock cuttings back on board.
They are transporting here the oil or the gas that they find.
Rock cuttings are then separated from fluids using shakers. Fluid is returned to tanks on board the rig. Where required, cuttings undergo additional
and then when they get all these materials, they are classifying them
processing before being carefully discharged below sea level. The volume and properties of drilling fluid are continually monitored to ensure the well is drilled safely. Once total depth is reached, tests are run to understand the geological properties of the intersected rocks. Information on any hydrocarbons found is collected through rock and fluid sampling. The information gathered can be used in a variety of ways, such as informing future exploration activities, development planning, or optimizing production. Once wells reach the end of their life, they are made safe by sealing them with cement. This is called well abandonment.
When they finish, they take all this away.
Before leaving the location, an ROV surveys the seabed again to assess and record the condition of the area. Woodside takes pride in the health, safety, and environmental performance of our drilling activities. We are committed to world-class environmental management in our exploration activities and in the design, construction, and operation of our facilities to help provide for the world's future energy.
Okay, you want oil for your car, for your bus or whatever. Okay, you want gas. You need gas to power your kitchen. You need all the work of these people there.
Needs.
So very good, very good. And now I think we have time for you to watch a very interesting presentation that was made by Miguel Farias. It was a voluntary work about Jules Verne, Julio Verne. Okay, so pay attention to it. So he says that Julio Verne, Jules Verne, was born in Nantes. He was a French writer. He wanted to become a lawyer, but he finally decided for literature, and he left law and started writing some plays and novels. Okay, and in this case, Miguel is right, because many inventions that we can enjoy today were first in his books. So, and you have some examples here. For example, the rocket was invented after Jules Verne wrote some novels. Okay, so you see here the submarine. Submarine is an invention by this person, and this was a Spanish inventor. His name is Isaac Peral. Okay, there is a street very near our school. This named after him. Isaac Peral was the inventor of the submarine. Okay, and before this invention, Jules Verne was able to write about a device that could travel not underground, but under the surface of the sea. The internet. That person is Hedy Lamarr, and she was an actress, a very famous actress, a beautiful actress. Okay, beautiful actress in Hollywood, but she also was a very fine inventor. She contributed a lot in the aftermath of the Second World War. Okay, good. The internet made its appearance with the green lightning. Okay, something similar. This is the green. Okay, but this is not exactly the same. Okay, this is the moment, the rayon vert in French. This is the moment, a special moment when the sun sets. Sun sets there. It's a moment there. Good. Finally, he died in one city in France. Okay, and he was one of the most important writers. I recommend you to read now in summer. Some of these novels are very interesting. So very good, and that's the end of our class today. So thank you, Miguel Farias, for your contribution, and now we meet in just 1 hour. So thank you.